Okay, guys, let's do a Unit 8 test review. Your test is tomorrow. So hopefully you're going to watch this video. Hopefully you're going to understand everything because it's actually a pretty simple test. There are 2 questions on there that are a little challenging, but if you're working it through and you have a good understanding of a two-way table, you should be totally fine for this test. Okay, so let's talk about the first part. Well, this is probably actually the second part, but two-way tables is a very big piece of this. It's about half of the test. So you may see something like this where you'll have to fill in the answers. So I know that I have to add across and add down. What's missing in this two-way table are the totals. So you have to put your total section going from the row, and you have to put your total section going from the column. And I'm just going to simply add down. So for instance, children, 3 of them, 3 children like yogurt and 8 do not. So there are a total of 11 children in this two-way table. Adults that like yogurt is 7. Adults that do not like yogurt is 2. So I will have 9 total adults, which means I should have 20 total people. So let's add down to make sure that that number works. 3 plus 7, so I've got 10 people that like yogurt completely, whether they are a child or an adult. And I've got 10 people that do not like yogurt, whether they are a child or they're an adult. And I know 10 plus 10 is 20, so everything adds up. So you may have to fill in a table. The next thing I may ask you to do is find the relative frequencies. So if I just say find the relative frequencies, period, you're going to find the relative frequencies by taking every single cell and dividing it by the total, which is 20. So for instance, children that like yogurt would be 3 divided by 20. Adults that like yogurt would be 7 out of 20. And then you would get a decimal, or you could make it a percentage if you needed to. Okay? Now, if I asked you to find the relative frequencies by row, that's a little different. You are going to find the relative frequency by row. So what you'll do is you'll take the cell and divide it by the total of that row. So for instance, the relative frequency by row for children that like yogurt, or children in general, is 3 over 11, and this would be 8 over 11. Now, this is also true. This would be 11 over 11, which is just 1. So they would have to add up that way. And then you would do it for this row, and then you would do the same thing for that row. Okay? Now, if I said find the relative frequency by column, you would add down, or you would use the cells to work down. 3 divided by 10 is the relative frequency by column, because column is something that holds something up and down. This would be 7 divided by 10, this would be 10 divided by 10. And then you would do that for the rest of the table. So that would be by column. Okay? One thing that you may see that I'm not going to put on here is, what if I had this table, but only pieces of it were given to you? You would have to add or subtract to find the difference between everything to make sure it added up correctly. Okay? That's pretty much it for a two-way table. Okay? Let's go to a scatter plot real quick. Okay. So for the scatter plot, okay, you may see something like this. So I don't have the plots on here yet, but you have to pay very close attention to what the scatter plot's telling you. So for instance, this is number of students. You can't see that. And then the test score, right? So let's say the scatter plots go something like this. What is the relationship that this has? What's the correlation? So you would tell me that it would be positive and it would be linear. So that's the association for this type of graph. Make sure you know all 5. There's positive and negative. There's linear and nonlinear, and then there's no association. So if dots were all over the place, there'd be no association. This right here is called an outlier. Make sure you know that. Make sure you can also tell me where that point is on the graph, like the ordered pair. So for instance, this would be 2 comma whatever. Okay? If it's going up by 5, 95, 100, 105, so it would be 2 comma 105. This would be a cluster. You don't have to tell me the points of that cluster, just be able to identify what a cluster is. Okay? This is also important. So, for instance, when x is 0, down here, where would the graph be? And the graph could be somewhere about here. So when x is 0, this is 60, okay? So it's a y-intercept. Please make sure you understand the difference between a y-intercept and all the rest. A y-intercept is when x is 0, and it's your starting value. It's where the line begins, okay? So make sure you're aware of that. A line of best fit for this, it could be something that looks like this, right? That's a good line of best fit. It's actually awesome. This would be a terrible line of best fit, wouldn't it? Because it doesn't go anywhere near the points. And this is also a terrible line of best fit, okay? So make sure you're able to write the line of best fit correctly, okay? Now, what is that line of best fit in slope-intercept form? Well, I know a y-intercept will be 60. So remember, y equals blank x blank. So the y-intercept is 60 here, so plus 60. Let's see what a slope could be. Well, if I go to the next point, which is here, I would go up 5 and over 1. So the slope would be 5x, so 5. So y equals 5x plus 60 is a great line of best fit for this line. Okay. What would be a terrible line of best fit? Well, if I put negative 5, because that implies that this line is going downhill. Terrible line. If I put y equals 5x minus 60, that's a terrible line because negative 60 is not the y-intercept. It's positive 60. So just so you can understand where we're going with this graph. Let's see. What else do we have here? We talked about two-way tables. We talked about scatter plots. Another thing that you may see, well, you probably see it actually, is let's say I give you a whole different scatter plot with a different set of points. We'll use the same type of thing. So what if my scatter plot looks like that? Tell me what the association is. You would tell me positive and linear, which would be correct. Now, the x values stop at 11. But what if we have a line of best fit here, and I say, give me an estimate of what the test score would be at 15, right? So you don't have 12, 13, or 14, or 15, but you know what this line is kind of trending towards, like you can tell. So if I made a line of best fit, which is probably right here, let's just keep going, okay? Which is what you're going to need to do, and figure out where 15 would be. So this could be 12, 13, 14, and 15. So if the line kept going, I would go straight up and see where my point is. Well, that point, it kind of looks like it crosses at 90, doesn't it? And that's what I need you to be able to do. At least visually kind of understand where the line of best fit goes, because that line of best fit will help you as you go forward in time to values that you don't have. So I would say, oh, it would, if the line kept going, I would be able to go to 90. So 15 would be 90. Now the choices will probably be a little bit easier. So choice A would be 70, choice B would be 90, choice C would be 80, and choice D might be 110. You would be able to tell, I know it's definitely not at least two of those other ones. So we'll work it out that way. Okay? Hang on for me for a second. Hello. Do I have to do anything? No. I don't need any money, but good, because I don't have any. All right. I got boxes of stuff. Yeah! Look at all this stuff. Markers and awesomeness. All right, anyway. Hopefully you didn't miss me too much. I know you did, though. Okay, test tomorrow. After this test, we are going to go really fast into systems. I know you can do it. All right, study for this. Adios. No fever.